Hey guys, welcome to Unit 8A, Section 3. We are talking about arc length today. So really quickly, one thing you have to understand about arc length as compared to arc measure is we are actually measuring the distance in length in terms of like inches, centimeters, feet, whatever our label might be. But it is a chunk out of the circle. So let's say that we have, this is our arc here. Now that arc might cover, say, 60 degrees, but we want to know the actual length in terms of measurement. So the other thing that we're going to need to use and remember is how to find the circumference, which is the circumference is another way of saying the perimeter of a circle, the distance around the circle. And the formula for that, we have two different formulas. So there's C, the circumference equals 2 times pi times r. Remember, pi, we can use 3.14. That's that weird constant that relates to circles. And then r is the radius, so halfway across the circle. Or we can use just the diameter, pi times diameter, and that's what d is. And the diameter is the complete distance across the circle. Okay. So arc length is the length of an arc along the circumference of a circle. So it's a chunk of the circumference. When we talk about the arc length here, we have to find the number of degrees covered by the arc in order to figure out the fraction. So this part here, the fraction is always going to be the number, so like degrees or arc measure divided by 360. So whatever the measure of the arc in degrees, we're going to divide that by 360 because the whole thing is 360. That's what's going to give us the fraction. Okay, so we want to calculate this. Notice we have 4 feet for the radius. So we are going to use this formula here. So it's going to be C equals 2 pi r. And so C is going to be 2 pi times 4. And we can simplify that to just 8 pi. Now you could type that in your calculator and you'd get 3.14 times 8. But we can save ourselves some time and just multiply this value by the fraction that we're going to get. So this is 97 out of 360 degrees that's covered in that arc length of AB. So we're going to take that times 8 pi. Now watch how I type this in my calculator here. Let me just split screen here really quick. So I'm going to do 97 divided by 360. And then we are going to times this by 8. And then you can just hit the pi button. So we have 97 over 360 times 8 pi. And we're just going to round this to 1 decimal place. And it is in feet, so we are going to label this 6.8 feet. That's not the entire circumference. The entire circumference would actually be larger, but since we're multiplying by a fraction of the circumference, that's what makes it smaller. All right, let's go on to the next one here. So think about your angle that we have. 88 is our central angle, which makes this 88 out of 360, and then we're going to multiply that by 2 pi, and the radius this time is 2. So we could also just type this in all in one step. So now it's going to be 88 divided by 360 times 2 pi, you could do parentheses 2, or you could skip that step and just take it times 4 pi, because 2 times 2 would give you 4. And we get 3.07, so we're just going to round that to 3.1. And this time it is meters. Okay, so it's pretty standard once you see the idea with the formula. This one we have to be a little more careful because there's 2 different parts we have to find. So in circle D, shown below, ADC is congruent to BDC. Find the indicated measure. So we know that these two arcs are going to be congruent, ADC and BDC. So if this is 40, using our knowledge from the previous lesson, we would take 360 minus 40, giving us 320, cut that in half, and then we will get each of the other two arcs, which would be 160 degrees. So each of these arcs is 160 degrees. We want to find the measure of CB. Now when it says the measure, this little m, this is where you have to be careful. The measure is talking about the degree measure. That's the arc measure. So that's going to be 160 degrees. When it's talking about the length, it's looking for that value of inches, feet, centimeters, but it's the chunk of the circumference that you're looking for. So our fraction is going to be 160 over 360 times circumference equals 2 pi r. We're going to go back to that formula a lot. So 2 pi, and the radius this time is 4. Type this into our calculator. It's nice that we just have a pi button to use. And we get 11.2 is what we're going to round this to. 11.2, and then it was in inches. So there we go. Not too bad. And just remember, this is not the whole circumference that we're finding. It's just a chunk. So we figured out the total distance all the way to C, from B to C. All right. Now this one, we do want to calculate the circumference of circle Z, given the arc length and the central angle. So we're going to have to actually do a little back solving for this one. So remember the formula for arc length. This is the general formula. Arc length is fraction times, I'm just going to put C, but it's the circumference. So the arc length we have, that's this value right here, this 3.44. The fraction would be this out of the 360. So 60 over 360 times the circumference is what we're trying to find. So I'm just going to call that C. You could call it X, whatever you want to do. Now we need to get rid of this fraction here. And the trick to this is, if you remember how to get rid of a fraction, you can just multiply by the reciprocal. So we're going to take both sides and multiply by 360 over 60 to both sides. 360 over 60. And this is going to give us our answer. So I'm going to do, well, let me just delete this. 360 divided by 60 times 3.44. And we get 20.64 for the circumference. Since they gave us a value of 2 decimals, we're going to leave our answer with 2 decimals as well. 20.64 centimeters.